Bueno, creo que ya estamos. Buenos días a todos los que estamos acá presentes en el Zoom y a todos los que nos están viendo a través del canal de YouTube. Hoy vamos a continuar con el tercer encuentro de este ciclo de charlas que denominamos el litio de la Puna Argentina en un enfoque multidisciplinario a la luz de la geología, que está organizado por el Instituto de Geociencias Básicas, Aplicadas y Ambientales de Buenos Aires, el IGEBA. Como ya hemos comentado en charlas anteriores, pero también entendemos que algunos están sumando en estos encuentros, entonces refrescar un poco el tema de que el litio en la Puna Argentina y en toda la región de Chile y Bolivia realmente ha adquirido especial atención en los últimos tiempos, ya que constituye una de las reservas a escala mundial bastante importantes. Entonces se ha hablado mucho en los medios de comunicación sobre este recurso y nos pareció importante traerlo a este espacio para conocer un poco más de qué se trata el litio y cómo es la situación actual de este metal en la Puna. En este marco, el doctor Santiago Sánchez Rioja, quien es investigador de la Universidad Católica de Salta y consultor especializado en recursos mineros, nos propuso este ciclo de charlas y para ello ha convocado diversos investigadores y especialistas internacionales que nos han acompañado y nos acompañan en todos estos encuentros. El ciclo, les recordamos que consiste en 4 encuentros virtuales todos los miércoles a las 11 horas con transmisión en vivo a través de YouTube. Desde ya agradecemos a las autoridades de IGEBA y a las autoridades del Departamento de Ciencias Geológicas de la Universidad de Buenos Aires por facilitarnos este espacio virtual y por toda la colaboración que nos hacen para la transmisión en vivo a través del canal de YouTube. Les recordamos a todos los que nos están viendo que durante la charla pueden dejarnos sus preguntas, sus comentarios o consultas en el chat de YouTube y al finalizar estaremos comentándolas y respondiéndolas. También decirles que todas las charlas de este ciclo están grabadas, van a poder volver a verlas cuando quieran, son abiertas, son gratuitas. Después les vamos a estar pasando los links en el chat de las charlas anteriores para que puedan volver a mirarlas. Así que bueno, en este momento les dejo la palabra a Santiago, quien nos va a presentar al orador del día de hoy.
Ok, muchas gracias, Paula. Y bueno, gracias a todos los que nos están siguiendo ahora. Para decirles que, bueno, la primera charla hemos tenido la oportunidad de ver con Emily Herz la temática de la importancia de los recursos del litio en esta zona, digamos, del triángulo del litio, y la importancia de los recursos de Argentina. Y en la segunda charla con el ingeniero Rossi hemos visto aspectos importantes de la clasificación de estos recursos minerales. Y hoy tenemos en esta tercera charla nuevamente un invitado de lujo como el doctor Michel Lopez, del cual nos va a hablar sobre el origen de este tipo de depósitos. Para presentarlo brevemente, el doctor Michel Lopez es doctor en geología, con más de 36 años de experiencia en exploración minera y petrolera, especialista en sedimentologías, análisis de cuenca y metalogénesis, es experto en reservorios petroleros y consultor para las compañías Total y asesor experto para Eramet Group. Michel ha participado en numerosos estudios y proyectos de litio en salmuera, tanto en Argentina como en Bolivia, y ha brindado más de 120 cursos en el ámbito académico y en la industria. Es profesor de geología de reservorios del Departamento de Geosciences en la Universidad de Montpellier en Francia. Thank you, Michel, for joining us today. And yeah, it's your...
Thank you. Thank you very much, Santiago. Sorry, I will give my talk in English because my Spanish speaking is not sufficient for technical purposes. So the topics of my talk today is the exploration of the lithium in the salar of the Andean Plateaus, including Argentina, Bolivia, and Chile, and as reservoir geology, with the reservoir geology approach. Okay, so as you probably know, the estimated global distribution of lithium resources in the world correspond to about 43 million tons of lithium, and these resources are with a very large predominance in salt lake brines. You see here that the salt lake brines correspond to about 62% of the resources of lithium in the world. And from this 62% salt lake brine resources, Andean plateaus correspond more or less to 55% of these resources. That is to say, a very great resources on lithium brine in the Andean plateaus. People speak a lot of the lithium triangle. In fact, the lithium triangle is comprised, as you know, between Bolivia, Chile, and Argentina. But in reality, the extension of lithium brine deposits are more extensive, in fact, and as Lopez, Steinmetz, and Salvi recently proposed to call this system as a lithium crescent. Why a lithium crescent? This lithium crescent is very more extensive than the triangle, as you see here, and comprise, in fact, three main parts of the Andean plateaus corresponding to the Altiplano in the north, the Puna in North Argentina, and the Puna de Acatama in the Chile region, including this lithium crescent. So what about the major brine chemistry in the salt pan, in these salars? In fact, this lithium brine chemistry corresponds to more or less the same composition with sodium, magnesium, chloride, and sulfate, with some variation between the three main parts of this type of lithium deposits. In the Bolivia part corresponding, for example, for Uyuni, sodium, magnesium, chloride are well developed, but with high magnesium content. On the contrary, in the Puna and the Acatama, there is high calcium and low potassium content. And in comparison, the Puna in Argentina has high magnesium content and high sulfate content also. So there is some slight variation between these two areas, but the main composition is relatively similar across the Andean Plateau. What are the pending questions about this lithium brine rich salars? Some pending questions correspond to what are the main geological processes at the origin of the concentration of lithium, when these processes started, what is the origin of lithium, what controls the lithium concentration, what are the types, petrophysical characterization and architecture of the lithium brine rich reservoirs, what are the best targets, of course, what about the deep buried resource potential, because always people speak from the superficial lithium reserve, but forget that there are some potential below, and what is the best approach for studying and for study and exploration of this type of deposits. So the main point to have in mind is the concept for endorheic basing and saltpan formation. In fact, generally people distinguish what we call mature versus immature salar. Mature salar, in fact, correspond to dominated systems dominated by evaporite, halite in particular, like in the salar de Uyuni here. And immature salar are more dominated by clastic, fine-grained clastic sediments with minor interbedded evaporite, like, for example, here, Salinas Grande. So the general sedimentological model for this Anderic salt pan are climate-controlled model with an orographic barrier. Here you see the relief that limit the entrance of the moist clouds in the basin, forming a rain shadow effect, leading to a rain shadow effect. And in fact, there is some facies, depositional facies partitioning from the border where coarse material is deposited, like alluvial fan deposits, bajadas, then passing downward to sand deposit, mud flat, and often in the central part, playa lake deposit, where evaporite is precipitated. So there is a clear sedimentary control of this deposition from coarse to fine-grained material, chemical material in the central part of the system. So this model is not always, in a lot of cases, a steady state model. This is important to understand that the present day model we have in Salar de Uyuni, in Salinas Grande, in Argentina, etc., in Peru, in Acatama, are how can I say, are just a present day situation. Generally, in such type of endorheic basin, we can distinguish three main stages. The first stage corresponds to an initial stage with fresh water to brackish water lake deposits, leading to clayey to siltifacious deposition in some water trench. The water trench is a few meter to a few hundred meters thickness, okay? It can be compared to interior sea sometimes, okay? The second stage corresponds to a starving stage with the evaporative concentration process. So progressively there is some shrinking of the lake, the increase of the salinity, and precipitation of evaporite through the water column in the lake. And progressively by shrinking, the third stage corresponds to a mature stage where which corresponds to a saline salt pan, a dry pan or a wet pan. So completely dewatered. And in this case, the process of concentration of evaporite, of salt, corresponds to evaporative pumping from the water table, which is close to the surface. These stages are controlled by climatic cycle, which can be seasonal cycle, and there is a continuous cycling processes. And this process arises in particular since Miocene time in the Andean Plateau. So now we will more focus on the case of the Andean Plateau. The Andean Plateau is 1,800 kilometers long and 500 to 400 width. It's an intramontane basin, as you know, and the Salar endorheic basin are superposed to a zone of crustal thickening, and this crustal thickening, of course, is linked to the progressive subduction of the Pacific plate in the western part since 70 million years. So this process led to a calco-alkaline volcanism and, of course, to endorheic molassic sedimentation with some evaporite trapping and, of course, lithium potential development. In terms of climate, we know that there was a successive phase of aridification and humidification of climate associated to the progressive uplift of this era, creating some orographic barrier that limited the entrance of the cloud and the moist and the rain in the Altiplano since about 25 million years for the Altiplano, and for the Puna, this dry period corresponds more or less to 5 to 10 million years. So, two examples of such type of endorheic basing. The first example corresponds to the Kochari salar, which is an immature basing, as you can see, because you see that there is a lot of clastic material with sand and conglomerate from the border to the central part of the basing, clayey facies on the upper part of the system, and some halite mixed with clay and sand in some part of the basing. So you can see here the complexity of the infill of such type of salar. And another type of salar, also in the Andean domain, corresponds to the Rincon basing. In the case of the Rincon basing, it's more mature salar with thick halite deposition. The gray and blue facies correspond to halite, porous halite here with the blue, and more massive halite with the gray color. On the border, of course, there is some clay and silt facies corresponding to the alluvial fan deposition, and some mixing with halite and clastic facies in the central part. What you have to notice is people focus always on the superficial part of the salt pan, but in fact the infill is more several hundred meter thickness. Mostly the infill can reach 200-300 meters, about 1,000, 2,000 meters of thickness of sediments associated to such type of deposition. So what is important to know is the potential of lithium in the deeper part of this such type of basing. So because the high subsidence rate since the Miocene time in particular, what is the deep buried lithium resource? And what is the origin of lithium in such type of basing? So what are the key points for the lithium origin in lithium-rich brine system? What you have to know first is that lithium is a very reactive and geochemical incompatible element, which commonly rests as a solute in natural waters in the form of lithium plus. So brine composition in the Andean rim, as we saw before, is predominantly dominated by chloride, sulfate, magnesium, some sodium also, and some lithium, of course. Salt pan are associated to the occurrence of such type of basing, endorheic basing, where the drainage from a large catchment is collected during the rainy seasons, the rainy period of the system. The intensive physical and chemical weathering is responsible for the salt mobilization and concentration in the central part of the salar. In particular, during heavy rainfall, the processes of weathering is increased, okay? And the process of, during dry season, of evapotranspiration led to the progressive increase of the grade of the lithium in particular. Lithium concentration in the Andean Plateau, lack of a clear geographic distribution. We cannot plan roll the distribution of the lithium in this Andean Plateau. And the major brine chemistry grade, chemistry of lithium grade vary across this Andean Plateau. The mean value is about 400 milligrams per liter. And the total dissolved solution value for solid is comprised between 100 and 300 grams per liter. what is also interesting to know is the high lithium graded brine are not necessarily related to saline nucleus, to mature endorheic basing. What we know today is that lithium is supposed mobilized by meteoric weathering and hydrothermal leaching. We will discuss about that later on my talk. And this is associated to different host lithologies, including volcanics, like Lithium-Brine, rhyolite, dacite, and also some Paleozoic metamorphic rocks that have a high content in lithium, and also the sedimentary derivative of these Paleozoic rocks. What people propose also is the dissolution of older evaporite as a suspected source of our lithium also. So if we compare the average and minimum maximum lithium content worldwide for salt lake brines, you see that most are less than 500 milligram per liter, like the uni basing, with the maximum minimum rate between a few percent, a few 100% to more than 1.5 gram per liter of lithium. The most important grade correspond to the Akatama salt basing, where there is a grade that can reach more than 4 grams per liter. So now, what is the accurate lithium brine model for the Andean endorheic basing? We discussed about the general model for such type of basing for endorheic basing. So what is the link between the depositional processes and the lithium precipitation, lithium enrichment? So I will use the example of the Salar de Olaroz. It's a figure proposed by Garcia. It's a very recent work from Garcia and co-author. And on this figure, Garcia proposed a complete model that we can use for most of the Andean salar. So the model, of course, is associated to the leaching of the bordering reliefs. Okay, these bordering reliefs are metasediments, partly, with more or less, as I said, lithium grade, which can be important. As you can see, some metasediment content more than 33 milligram per liter of lithium. The leaching of Lithium-Brine also, and meteoric leaching and runoff on the surface that converge to the central part of the basin, but also by the effect of the hydraulic gradient, the penetration of the meteoric water through the border of the basin, which can mix with ancient lithium fluid, and this lithium-rich fluids can give lithium seeps by the effect of hydrothermal cells. The hydrothermal cells are associated to active or dormant volcanoes because there is an anomaly of temperature that can give to some convective movement in the border of the system and led to enrichment of lithium from the deeper part of the basin. The processes, also the superficial processes for lithium enrichment, is associated to the high rate of evaporation that can increase by 3 the grade of lithium in the salar. Okay, and then there is also another process which is underlined by Garcia and co-author, is the trapping of lithium by clay, because clay can trap, in particular smectite can trap the lithium, and then clay, then there is an increase of the crystalline of the crystallization of the clay, the lithium is released. So in fact, at the first time, clay trap the lithium during the sedimentary process. Then during burial and increase of crystallization, this lithium is released and can be added to the cycle of lithium mobilization and can be associated to hydrothermal cell. So bedrock weathering is the main source of the lithium, in particular volcanics and metasediment. Hydrothermal leaching of surrounding rocks also. This is the second process, mobilizing the lithium from the watershed, from the drainage basin. Then there is a progressive release of the lithium, which is striped with a clay deposited in deeper part of the system, and the fault control, in particular the hydrothermal fault, the bordering fault, because these basins are often bordered by faults. This fault led to the pathway, correspond to the pathway for the fluid to reach the surface. So Lopez, Steinmetz, and Salvi proposed a general model for the factors driving the lithium grade in the Andean brine deposits from the source and the size of the watershed. So lithium is mobilized by hydrothermal spring, dissolution of ancient evaporite and rock weathering, as we discussed before at the basin scale. Then the lithium is transported by surface inflow, river, runoff, of course, and underground inflow associated to spring and groundwater, associated to hydrothermal cell, that led to the recycling of the lithium close to the surface. And this process of recycling by evaporative pumping led to salt precipitation and lithium enrichment in the brine. The size of the salpan is also important. So the time in this process and the aridity are a factor that increase the concentration of lithium in the brine. One thing important showed by this author, Lopez, Steinmetz, and Salvi, is that there is some link between the size of a basin and the watershed and the size of the salpan itself. So with this analysis of different salpan in the Andean domain show that the largest and oldest salar are expected to hold the greatest lithium concentration. Okay, the more the salar is old and large, and the greatest is the lithium concentration. So lithium is controlled by a basin scale process, the geomorphology and the age of the basin. Okay, because the older is the basin, and the more the process of the duration of a concentration process is important, as you can easily imagine. So we discussed about the basin process. So now what about the reservoir itself? Because not all facies can contain lithium brine. There are some good reservoir facies and no so good reservoir facies. As you can understand, when you have clayey material, there is some lithium potential, but it's difficult to extract this lithium because there is a low porosity in clay facies. So as we underlined at the beginning, there is a facies, a sedimentological facies partitioning from the border, the alluvial fan, bajada facies, sand flat, dry mud flat, and evaporite in the central part of the system, where the process, the evaporative pumping process developed. Okay, and I propose you to illustrate it, this model with two salpan, the first is the case of the Salinas Grande in Argentina, and the second is the Salar de Uyuni. So immature endorheic basin and a mature endorheic basin. So the case of Salinas Grande is limited by high relief corresponding to the tectonic activity and the progressive subsidence in the central part of the depositional system. The endorheic basin is here, while the Salinas Grande located here. You can see with this aerial photograph the facies, sedimentary facies partitioning from the border, controlled by faults, okay, on the two borders. From the border to the central part, you see the bajadas, the alluvial fans, then the salt flat, the dry to wet mud flat, depending on the season, and an ephemeral to perennial playa lake in the central part, where some brine are concentrated. So if we look about the source of the lithium, it is the same source as I proposed at the beginning. This is essentially, in the case of Salinas Grandes, volcanic ash and igneum-brite that were in fact progressively leached, weathered, and release the lithium content. In particular, the volcanics are Miocene to quaternary deposits. And here you can see the convergence, the progressive convergence from the different parts of the basin leading to the input of this brine in the central part of the depositional system. So what is the superficial depositional sequence? In the case of Salinas Grande, here you see a log section of the first 2 meters of the superficial salar. So in the upper part, you have a more or less saline crust corresponding to the first meter. This saline crust is composed essentially of lenticular discontinuous to lenticular halite with high porosity. This halite contains more or less unconsolidated gypsum and ulexite lenses. Ulexite is boron hydroxide. We will discuss about ulexite also in Uyuni. And in fact, below 1 meter, the material is essentially clay deposits. So there is a barrier, a permeability barrier below, but limited the reservoir potential downward. So the reality is in such type of deposits, there is low porosity, low permeability, because a lot of clay below 1 meter. So the reservoir is very, very limited. So what is the consequence of such type of sedimentary sequence in the superficial part of the deposition? Here is a sedimentary model for Salinas Grande at more or less the present day situation. You have a relief with the basement, bordering the relief alluvial fan deposits, and these alluvial fan deposits are interfingered more or less with salt deposits and clay deposits. And the problem is during rainy season, the fresh water penetrate alluvial fan deposit, go down deep, and lead to an artesian water below. And in fact, on the border of the basin, there is some freshwater spring, as you can see here. This is the border of Salinas Grande. And here there is fresh water, and around it is salty water. And here is fresh water associated to some spring fed by the alluvial fan, the coarse material from the border of the system. But this fresh water penetrated below in deeper part of the basin. And if you try to drill for exploiting some lithium brine potential below, you will reach this artesian water, and there is some eruption and with environmental consequences, because the artesian eruption during drilling led to the dissolution of the salt close to the surface and the collapse of the surface. You can see an artesian eruption associated to one drilling in the central part of the basin, because the estimated water table is more 7 meters higher than the surface of the Salinas in Salinas Grande. You see here the water table, potential water table. So what about the deeper part of this Salinas Grande? Because we discussed here about a few tens meters below the surface. But what happened down deep? If you see here in Salinas Grande, there was some petroleum exploration and some seismic reflection, which was acquired during 20 years ago. The seismic was acquired, and you see that the total thickness of the basin is more than 2 kilometers thick. 2 kilometers thick of playa lake sequences with model that can, and we can expect to find some lithium in the deep buried part of this basin. We don't know exactly because there is no deep drilling, but in some other saline, salt lake, some drilling show some high potential of lithium in deep buried part of the basin. Okay, and the history began more or less here in the Paleogene time to the present day. Okay, so this is more or less the same sequences, climatic control sequences with more arid and more humid periods. So what about the lithium potential in this Andorre Lake deposits? So now the example of the Salar de Uyuni. The Salar de Uyuni, in fact, is a mature salar, which is dominated by evaporites, halite, essentially precipitation. Okay, and this salar corresponds to a steady state situation, and the history of the salar began during Pleistocene time, as I will show in the coming slides. So if we consider first the upper reservoir, the reservoir which is between the surface and a few tens of meters below the surface, this upper reservoir shows there is some lithium gradient between about 2 or more grams per liter in the south, close to the Rio Grande River. And in fact, there is a slight decrease toward the north, reaching a few hundred milligrams per liter in the northern part of the system. So there is a gradient from the south to the north of the system. If we consider the structure of this reservoir, the lithium is trapped in the ultimate salt of the brine, which impregnate the surface salt layer. The salt layer corresponds to this. You have here a section of a complete reservoir between 0 and a maximum 11 meters. Here it is 600 centimeters, but the maximum thickness reaches 1100 centimeters. The lithium grade is about 500 milligrams per liter. And in fact, depending on the season, there is during the wet season some dilution by rain and stream water, in particular close to in the south, close to the Rio Grande River, and during the dry season, the effect of evaporative pumping that help to concentrate the brine and in particular the lithium in the reservoir. So the main process, present day process, is an evaporative pumping process led to dehydration of the surface deposits. So what is the characterization of this reservoir of Salar de Uyuni? So if you see a core here, you see that there is a lot of veins and cavities corresponding to the reservoir. There is an upper crust, a more stiff upper crust than a crispy crust, as I will see. This is the water in the brine water in the reservoir. And this crust corresponds to a few 10 centimeter well-crystallized crust with well-crystallized cubes and chevron-like halite. You see here the cubes of halite. The size is 1 centimeter with a lot of porosity in between. You see the veins between the halite crystals. The porosity is about 30 to 40%. This crust corresponds to a subaerial process, a present-day subaerial process associated to successive dissolution precipitation of the halite depending on the season. So it is really the real salt pan crust. And below this salt pan crust, there is the major facies up to 10-meter depth, corresponding to a laminated facies that include 90 to 99% of halite and 1 to 10% of gypsum. You see here the gypsum crystals, you see the halite cubes, you see the gypsum crystal, and the porosity is higher because the porosity here is between 30 to 40% in such type of a reservoir. And these deposits are not present-day deposits, but correspond to deep lacustrine precipitation of supersaturated brine during a lake stage. At this moment, there is no lake stage, but only a salt pan. But during previous time, during Pleistocene, I will show you later, there is stage of a lake stage with high evaporation and direct evaporate precipitation in the deep part of the water column. Considering always the Salar of Uyuni, if we look about the Rio Grande area in the south, where is the maximum of lithium content close to the river Rio Grande Delta. Here is the Rio Colorado, here the Rio Grande with high lithium input. What is the origin of this high grade of lithium in this area? In fact, in this area, there is a transition between the Rio Grande Delta with the deposition of sand, silt, clay silt passing to the halite deposit. And in between, at the transition, you can see the maximum of lithium in this area here. This maximum of lithium is associated, as proposed by Risacher in 1992, by the cumulative effect of evaporative pumping and lithium release from clays, because this facies is a clayey facies. You see the surface close to the Rio Grande, the surface is a clayey surface. There is no halite. It is a fine-grained sediment. And here, the lithium content is between 1.5 to 2.5 grams per liter. And there is also ulexite. I will show you. The ulexite is located close to the water table here. This ulexite is a boride hydroxide, sodium calcium boride hydroxide. And this form discontinuous layer lenses close to the water table. And this ulexite deposit are or were exploited. I don't know now if still they are exploited, but these boride were exploited by the Comibol that exploited. You see here the boride layer. The clay was removed from the surface. This is more or less the water table position. Below is water. You see the water here. And the boride lenses that are 50 to 300 meter length and 5 centimeter to 50 centimeter thick were exploited. What more about the Uyuni depot center is that there is also some hydrothermal seals which were evidenced along the southeastern border of the basin, where there is some fault that control the subsidence of the basin. And along this fault, there is some seeps, hydrothermal water seeps with a lithium content that can reach 1.5 gram per liter. So high lithium content associate. You see here the seeps with a bubble corresponding to this hydrothermal process. So to conclude to the Sala de Uyuni, the main message is that the present situation is largely a legacy of the past. What happened is during the Miocene, but I just focused from the Pleistocene to present day, but it was the same during Miocene time. There was periodical changes between humid and arid phases. If you look here, the insolation close to the Uyuni era, you see that there is a cycle of insolation corresponding to the precession cycle of Milankovitch, okay, with more insolation, less insolation, etc. Precession corresponding to this, it's about 40,000 years, and also a cycle of eccentricity corresponding to 100 kilo years, and this Milankovitch control climatic cycle led to a phase of arid phase and humid phase. The humid phase led to the development of large lakes. First, it was brackish to some salty lake, Lake Tauca for the more recent, Minching, Balabian, etc. And in fact, this lake led to the progressive concentrate the progressive brine leached by weathering processes and hydrothermal processes on the border. And then during arid phase, the lake shrink, there is some more evaporation, increase of the concentration of the brine up to the brine reach the supersaturation stage and precipitate. Okay, so you see that there is a clear link between Milankovitch cycle and lithium brine prediction. So we can in fact predict the lithium brine potential in more analyzing the cyclicity and of the climate during the past, and in particular since the Miocene time. So the teaching of this is that can lead to a general model in the case of Lake of Uyuni, but also in some system in the Puna and in the Chilean Puna also. There was some period, humid period, like in the upper Pleistocene stages, that led to the development of deep water lakes, okay, a few tens, up to 100 meters water trench in the lake. In particular, in the case of the Uyuni basin, the Uyuni lake was connected to the Titicaca lake, and in some times there is some spillover and cascading effects, cascading process from the Titicaca area where there was more moisture and precipitation during some Pleistocene period, toward the south, where the aridity increased. And during this period, the brine were progressively input in the lake system. And then with the increase of the dry period, of the dry cycle, the water trench of the lake shrink. There is an increase, a progressive increase of the salinity, and the brine precipitate in the water trench. The salt, precipitate in the water trench, and lithium was in particular increased and trapped in this salt deposits. And then during present day, which is an arid phase, there is low precipitation in the Uyuni area. Evaporation is higher than the runoff and precipitation, leading to a salt pan, leading to a salty surface where evaporative pumping increase the lithium content. But this present day history exists also during some Pleistocene, Pliocene, Miocene phases. That is to say, there is some potential in deep buried deposits in such type of endorheic basin. So to conclude my talk, I want to make a provocative synthesis in the challenges for lithium brine exploration. In fact, what I want to say is that superficial reservoirs are a thin, are the thing of the past. I forgot, sorry, but what I want to say is that the present day situation is not the main story for lithium precipitation, okay? And in fact, for the exploration of a deep buried reservoir, the mutation between mining, traditional mining exploration from more petroleum exploration techniques, petroleum exploration, oil exploration techniques are necessary, because the main concept for our geology cannot be applied for deep buried lithium brines. As you know, lithium brine are a living resource. It is not fixed in the reservoir, but it is mobile, and it is linked, clearly linked to the reservoir properties. So lithium brines are mobile. We evolve on time by increase or decrease in concentration during the geological history. We are difficult to circumscribe, of course, as I show you. What is important, as I show you with eruption of fresh water, is that improper operation, drilling operation, can permanently kill the deposits, okay, by input of fresh water in the system of deep fresh water by artesian processes. The concept of reservoir is fundamental as for oil exploration. The hydrological approach, the present day approach is an hydrogeological approach, is an obligatory passage, but not sufficient for deeper reservoir exploration. For deeper reservoir exploration, we need to move to oil exploration techniques. Exploration and reservoir modeling and prediction involve the mastery of sedimentological concept and sequence photography concepts, comparable to what people use for oil exploration. And the corollary of this is that we have to use techniques for oil exploration, and in particular for the prediction and exploration of deep buried resources we need to use seismic reflection exploration, well logging measurement, and in particular for reservoir characterization, and sheeted core drilling, not open core, but sheeted core that protect the fluids and that protect the porosity, permeability properties of a reservoir. And also stratigraphically controlled well testing. You cannot test just the well in pumping the brine because you mix several types of water and it is not representative. So my message is to win, you have to go deeper now in the future. Thanks for your attention. Thank you very much.
Okay. Thank you very much, Michel, for your excellent and clear presentation. Bueno, muchas gracias a todos y bueno, le agradezco ahí a Michel López, realmente una presentación excelente, muy buena, con muchos datos súper interesantes sobre lo que es la exploración de litio en salmuera y bueno, con muchos conceptos nuevos hacia futuro también sobre estos depósitos que son tan desafiantes, ¿no? Así que bueno, me gustó mucho el concepto de living resource, un poco para definir, digamos, lo que son este tipo de depósitos tan particulares y tan especiales, ¿no? Michel, I will read some question for you. Okay, the first question, did you evaluate the potential risk of freshwater reservoirs salinization due to brine extraction pumping at Salinas Grandes?
No, I have not clearly estimated, but there is some risk in a lot of, not only Salinas Grande, because the main concept is bordering all the salinas. There is some coarse material, coarse plastics, conglomerates, sand, etc., going down and limited by permeability barrier. So when you will drill in the central part of the system, not shallow drilling, a few meter drilling is not a problem. But when you plan to make some deep exploration, you will clearly encounter fresh water in the system, artesian fresh water. It's more or less a rule. And artesian fresh water is a risk in terms of environment, and it is a risk in terms of resources, because you kill the reservoir in this case. You dilute the reservoir, and it's no more possible to exploit the reservoir in this case, you know? So it's a real risk.
Okay.
But for Salinas Grande, I see the case, I show you, but it's not only for Salinas Grande, it's general for me. Or a lot of, not all, perhaps the Salpan show this model, but a lot of them, yes, for me.
Okay, excellent. Michel is very, very important. Yeah. The second question, what happens with the loss of heads due to brine pumping? Does this effect damage the freshwater reservoirs?
Oh, the effect of pumping, yes. It is the reason I say people have to use concept for oil exploration and pumping model, because depending on the porosity, permeability of a system, you can, if the pumping is higher, you can lead to a mixing of fresh water and the brine in this case. So you have to clearly develop a model, a reservoir model, integrating the capacity of the reservoir, not over pumping the system.
Okay. Okay, thank you, Michel. muy importante los contextos que estás hablando, digamos, para entender justamente la importancia, ¿no? de comprender lo que es, digamos, tener un buen modelo y una buena caracterización, digamos, ¿no? del reservorio y de la cuenca en general, ¿no? Para justamente también poder manejar mejor, digamos, este tipo de recursos, digamos, que son muy complejos, ¿no? Muy desafiantes.
Yes, there is some phase transition and phase variation, and you have to take into account the phase changes along a timeline, along stratigraphic line, to create the model. It's not only a pumping model, but you have to integrate the reservoir architecture. As we use in oil exploration, you build a model of a reservoir architecture based on present day or on analogs. There is analogs that we can use to build the model, but it's very important to use these analogs to build the best model for the reservoir and to constrain the exploration also. Because there is a lot of variation in the system.
Perfecto, muy bien, Michel. Sí, lo que dice Michel, entonces, de considerar muy bien la extensión, digamos, lateral de todas las unidades que nosotros tenemos en los reservorios, ¿no? Y ver bien todo lo que es la arquitectura, digamos, de ese reservorio, de esa cuenca, para considerarla, digamos, en particular en este tipo de depósitos, y no solo generar, digamos, solo un modelo de bombeo, digamos, de pozos, sino que esto, digamos, hay que verlo desde una perspectiva mucho más amplia y mucho más general, ¿no? Perfecto, Michel, seguramente que más preguntas van a ir llegando y nosotros la vamos a compartir luego, seguramente la vamos a acercar a Michel. Gracias, y él las va a contestar y nosotros las pondremos acá a disposición para ustedes, digamos, ahí en el chat abajo. Así que bueno, estamos agradeciendo de vuelta a Michel realmente su presentación, que ha sido muy ilustrativa y muy interesante, con muy buenos conceptos, ¿no? sobre este tipo de depósito, como dijimos, que es tan particular, y a la vez que es tan importante para nosotros como Argentina, como país también, para poder, digamos, conocer mejor este tipo de depósitos y lograr justamente una mejor gobernanza de estos recursos. Así que bueno, thank you very much, Michel, for joining us today.
Muchas gracias. Muchas gracias a todos, sí, también. Bueno. It was a pleasure also.
Gracias, Michel.
Share my little knowledge. Thank you very much.
Muchas gracias a todos, gracias Michel, gracias a todos los que nos están viendo y a través de YouTube. Les recordamos, bueno, que el próximo encuentro, el miércoles próximo a las 11 de la mañana, va a ser la última charla de este ciclo, que va a estar a cargo de Santiago Sánchez Rioja, para cerrarlo con su título, que será Tan iguales y tan distintos los salares de la puna en una mirada holística para adentrarnos en su complejidad y singularidad. No sé, Santiago, si querés de paso adelantarnos un poco de qué se va a tratar la charla, y ya estamos cerrando.
Sí, perfecto. Sí, mira, Paula, la charla va a ser un poco un colorario, digamos, de cierre final a todo este ciclo de charlas, resumiendo un poco todos los conceptos que hemos venido trayendo desde la primera charla, de la importancia de lo que es el litio, digamos, para nuestro país, y hablando un poco de los salares de Argentina en particular, ¿no? que es tan especial, digamos, cuáles son las similitudes y semejanzas con otros salares, digamos, dentro del altiplano y a nivel global también, y para adentrarnos un poco en la singularidad, digamos, que tiene cada salar acá en Argentina. Y también vamos a hablar de las cuestiones que hay que tener en cuenta en la parte ambiental, este tipo de depósitos, ¿no? Cuáles son los impactos ambientales relacionados, digamos, con la extracción de litio, y cuáles son los aspectos importantes que hay que tener en cuenta y a considerar para lograr justamente que el desarrollo de estos depósitos sea, digamos, amigable con el medio ambiente y, bueno, y sea sustentable, ¿no? Entonces, bueno, esas temáticas las voy a tratar ahí en la última charla, que bueno, estaríamos cerrando ya este ciclo, y bueno, espero que la gente que nos ve los haya podido apreciar, y bueno, ese es el deseo que tenemos.
Sin
Así que
duda.
bueno, eso.
Bueno,
Gracias.
nos encontramos el
Gracias.
miércoles entonces. Chao,
Chao,
chao.
chao.
Gracias a todos.
Gracias a
Chao,
todos.
chao.